Here, I'm going to demonstrate tokenization using bin to hex by replacing sensitive data with tokens. So let's have a look at our SQL query. The first thing we do is we create the database for tokenization, and the database is called demo. We then select the database and create the table. The table is called orders, and what it does is it will represent the normal application data. Notice here that it doesn't store the real credit card number. What it does is it gives each user a unique ID and then a name for the user and the token instead of real card number. Then we create another table called secure cards. Now this is the table that's going to store the sensitive data. In real systems, access to this table is tightly restricted. And what it will have is the token value that we generate and insert into the previous table. And that token is going to be in the same row associated with the actual card number. So let's go into MySQL bench and run that query to actually create our table. So here we have a table called demo and two tables. One's called order, and the order has got an ID, user, and a card number. At this point, there's nothing saved in this table. And let's have a look at our second table, which is secure cards. And secure cards also has two fields, which is token and real card, but nothing is saved into this. So let's go into any of the tables. So let's go to our PHP script and have a look at what we're doing. The first thing I'll do here is turn off detailed MySQL error messages, and then reload the database connection settings from a configuration file. And this is sitting in the same folder. And then we connect to the database. And over here, we want to simulate a real credit card number. Save that into a variable called real card. Now, this value should never be stored directly in application tables. Assuming this is a valid number, we then want to generate the token. So we're going to generate the token using random bytes 4 here. We'll generate a secure random data, and then we will pass it as an argument to bin to hex function, which converts the random binary data into readable text. And at this point now, the token has no relationship to the card number. So we just put that in a variable called token, and it starts with the text TOK or token underscore. Now we want to store data in the main application table. So this is going to go into our orders table. So the application only sees the token, not the real number. So here we store the user, in this case it's Alice, and that token that we generated using bin to hex and random bytes. Next, we will store that sensitive data into the other table, which we called secure cards. So this table would normally be protected and inaccessible to the main application. So we pass the values token that we generated here, and then we pass the real card number that we have in this line. So then what happens is we just echo to the user saying the stored card using the token. Basically, just send that value to the screen. So my PHP server is already started, and I'm just going to refresh it. This is from a previous video. So here we have this value, so stored card using the token. So as you can see that TOK is coming in from this string. Where is it? I don't have it here. Yeah. And then the generated value that we use bin to hex to convert into data that we can actually read as numbers and letters. So let's go into the database and see what these tables looks like. So the orders table will have Alice and that token value that we saw on the browser. And then into secure cards, we have that token value associated with a real card. So this example shows tokenization in practice. The application never stores or sees the real credit card number. It only works with a meaningless token. So this one, sorry, meaningless token. So even if the main database, if this database is accessed, attackers get tokens instead of sensitive data. This is why tokenization is commonly used for payment systems and personal data. The tokenization reduces exposure by ensuring sensitive data is stored only where it is absolutely needed, which is here. So this secure mapping table is accessed only when the real data is required and only by trusted systems. So the key takeaway to take from here is that tokenization protects sensitive data by replacing it with values that mean nothing if stolen. I hope this video was helpful, and I'll see you in the next video. Thank you for watching.